What's up, guys? It's me, Grey Wolf, back here to do another video for you, or should I say redo another video for you. I'm gonna go back in this video and redo a video that I'd previously done before on how to convert your common household PC power supply to a power supply that can power your Lipo chargers. Now, like I said, I did this once before, but it was done probably in the first, I don't know, 6 months or so of me starting the channel. And back then I had a really crappy camera and didn't have any mics or anything like that. So, and even the overall walkthrough, if you will, wasn't very coherent. So I decided to redo it. Okay, let's go ahead and get started on how to convert this into something like this. Now, this is one that I just got done converting, so I'm going to go ahead and pull the top off of this and we're going to discuss this for a minute. Okay, so the very first thing that you're going to do with your PC power supply, it's going to look something like this. Maybe not quite as many wires off the back. This is actually a fairly big power supply. This is a 700 watt power supply. But you're going to take all of these wires on the back, every single wire that's coming out of the back of this power supply, and you're going to cut them all off. Now, I typically like to leave myself about 10 to 12 inches of wire hanging out the back, so I make sure I have enough wire to actually do what I'm going to do. Probably 12 inches is a good safe amount to leave. You can always trim it down some more if you need, but every single one of these wires, even the big 24 pin connector or 20 pin connector, cut them all off. Okay, so before we get into actually taking this thing apart and showing you what I did to make it viable for your Lipo charger, we need to talk about a couple of things first. The first thing we need to talk about is what's called a rail inside of the PC power supply. There's at least 3 different rails. Well, technically probably more than that, but there's 3 basic rails that you're going to find in every power supply. At least 3 that we're concerned with. There's probably going to be more, technically more than that, but 3 that we're concerned with. There's going to be at least 1 rail for the 12 volt wires. There's going to be 1 rail for the 5 volt and 1 rail for the 3.3 volt wires. That's your 3 basic voltages that you're going to find inside of a PC power supply. For the most part, all we're concerned with is the 12 volt, but 5 and 3.3 can be utilized for various purposes. Especially if you're into electronics in general. So we'll cover it all. So the first question you probably have is, well, what is a rail exactly? And really, all a rail is it's really just a pipeline. Just think of it as a pipeline. So the 12 volt rail is just a pipeline that all the 12 volt electricity flows through. Now, you can have power supplies that have just a single 12 volt rail, and you can have power supplies like this one. This is actually this is an old power supply out of an old server. It's a 1250 watt power supply, and this one actually has 6 rails on it. I'm going to show you. If you look right there, you can actually see that there's 6 different 12 volt rails. Each one of them will say plus 12, and then it'll say V1, V2, V3, V4, V5, V6. Each one of those is a rail. One of the reasons it's rated 1250 watts is because it actually has 6 different 12 volt rails in it, or 6 different pipelines for 12 volt electricity to flow through. Now, that's not typical of a power supply. It only has that many rails because this is intended to power a server. Your typical power supply, like this one here, this one only has two 12-volt rails. And that's pretty typical of your standard PC power supply. A standard PC power supply is usually they're going to have, well, typically they're going to have two. Sometimes they will have one. They can have three. Typically you're not going to see more than three. But I'm getting off topic. So at any rate, all you really got to know, all you got to understand is that a rail is a pipeline for the electricity to travel through. The more rails that you have in a power supply, the less amperage each individual rail is going to be able to handle. So that's kind of a drawback, but there's a workaround that I'm going to show you later on for that. So I'm going to go ahead, let's see. I'm going to go ahead and open this guy up here. We're going to switch to the overhead view, and then we're going to take a look at exactly what went into making this bad boy. Okay, so here we are in the overhead view. I've already, basically every power supply, if you've never taken one apart, comes apart the same. There's 4 screws, one in each corner, and then you may have to pry it a little bit the first time you take it apart. But then this top section here with the fan is just going to come right off of it. Just like that. And I'm going to slide this out of the way for just a second because we're going to talk about the fan first. So the very first thing you're going to want to do, and when you take this off, make sure that you don't pull too hard on it, because you will have to disconnect the fan from the PCB inside. But make sure you disconnect that. And then what you're going to do, typically the fan actually comes on the inside of the power supply. And what you're going to need to do is you're actually going to need to remove that, and you're going to need to flip it around and put it on the outside of the power supply, because we need to free up that extra room inside the power supply for additional wires that typically aren't inside the power supply. They're typically outside. So in order to do that, if you want to keep your fan guard on the top, you're going to need an extra set of PC fan screws, because you're going to need one set to screw the fan into the housing, and then you're going to need a second set to screw the grill onto the top of the fan. Now you don't have to do that if you don't want to, or if you don't have an extra set of PC screws, but it's usually a good idea so you don't break the blades on your fan. So that's about all we really need to. Oh, one more thing on this. Okay, I just grabbed another PC fan here real quick so I can show you this. So every fan is built basically the same way. You got a side that the fan is totally unprotected, where you can get in there and spin it freely. And then you're going to have another side that's going to have these braces that basically hold the motor, which is inside the center of the fan blade here. And the one thing that I just want to point out real quick, in case you take your fan out and you forget which way it was in, the side without any bracing, this is the intake side. The air is going to get sucked in this side, and the air gets blown out or exhausted out the side with the braces. So whenever you're mounting your your fan for your power supply, you want to make sure that the side with the bracing goes down, pointing toward the inside of your power supply, to make sure that the air actually gets blown into the power supply. The cool air from outside goes into the power supply. So I just wanted to point that out in case anybody took theirs off and forgot which way it goes. Now, let's see here. Okay, so now we're looking at what we did to actually build the power supply. And there's really, I guess, 3 different ways that you could build this. One is you can build it with all banana connectors if you wanted, like these, or you know, anything even remotely similar. They don't necessarily have to be as fancy as this, but you can build it all with these, or you can build it by taking 4mm bullet connectors and just taking your cutoff wires and soldering the cutoff wires into the bullet connectors, and then leaving the wires in the bullet connectors to hang out the back of the power supply. Now, doing it with the bullet connectors on the front is going to look much cleaner. It's much nicer. You know, it's more aesthetically pleasing, but it also is more time consuming. So it's really just up to you. If you have a nice power supply, you probably want to go this route. So the whole thing looks nice. Otherwise, if you don't, or you don't care, or you just want to do it as quick as possible, then you can always just go this route. And then the third way to do it is basically what I call a hybrid, which is both, like this one. This one has posts. Basically, I have 2 sets of 12-volt posts up here, and then I have one 5-volt and one 3.3-volt here that's going to hang out the back. And the reason I chose to do this one this way is because 12-volt is really what we're mainly concerned with, and probably what's going to get used 98% of the time, if not 99.9% of the time. But the guy that I modded this one for, he's an IT guy like me and likes to dink around with electronics here and there. So we went ahead and just put him a 5 and a 3.3-volt connection coming out the back. That way he can set it up and use it, and you know, display the front of it, and it'll look nice. And if on rare occasions he ever needs one of the other 2 voltages, he's got them hanging out the back of the PC, or out of the back of the power supply. Now, as I mentioned before, we have 3 voltages inside of a power supply. Yellow is always going to be 12 volts. Red is always going to be 5 volts. And orange is always going to be 3.3 volts. And then, of course, black is your ground. There are a handful of other colored wires in the power supply, like maybe half a dozen, but the vast majority of them are going to be one of these 4 colors. Okay, so power supplies that have multiple rails are usually going to have, like I said, all the 12-volt wires are going to be yellow, but some of them are going to have stripes on them if it has multiple rails. So like this one here, you can see it's a yellow wire, but it's got a green stripe on it. And then you can see this one here. This one here is yellow with a red stripe. And some of these are probably hard to see, but this is yellow with a white stripe, yellow with a blue stripe, yellow with a black stripe. So each one of these wires is from a different rail. And this comes back to what I was talking about earlier, where you can kind of split up the load, because like I said, each rail is only capable of handling, on this particular power supply, 3 rails are capable of handling 28 amps, 3 of them are only capable of handling 20 amps. So what we want to do in order to provide the best possible power output, we want to basically try to use 1 wire from each of the rails. That way the load is spread over every one of the rails, or at least the majority of them. I think there's actually only 5 wires here instead of 6. But we're utilizing 5 of the 6 rails in parallel. That way the load is spread out over all the rails, and you theoretically should have, instead of being able to handle 20 amps, you theoretically should be able to handle more like 100 amps or something. Now that probably isn't entirely, that conversion probably isn't entirely accurate, because there's other factors to take into consideration, but we're not even going to get into all that. At any rate, so once you if you're going to do the bullet connectors, once you get your wires cut and stripped, then what you're going to do, if you can see in here, is you're going to take like a ring connector. Let's see if I can get this to focus. So you're going to take like a ring connector, like what's in there now, and you're going to crimp it down on those wires, and then you're going to use those ring connectors to attach to your banana posts. And all that's pretty easy and straightforward. Just drilled a couple of holes in here, obviously, ran the banana post through, etc., etc. Screwed the ring clamps down on there, and it's good to go. And for the back of it, let me zoom out here. So, and for the back of it, again, we took a handful of wires. Now there's only one 5 volt and only one 3.3 volt rail. So we just took, with 4mm bullet connectors, 4 wires typically works the best. We took 4 wires from the 5 volt and 4 from the 3.3, and we soldered them into bullet connectors and gave them their negative counterparts. And these are going to hang out the back just like this. Now all of that's pretty easy and straightforward. Once you're done with that, you're gonna be left with a ton of wires like you see back in the back here. And what I do is I just cut those off even shorter than the rest of them, group them up in groups like I did, put some heat shrink around them, around the ends, just to keep them, just to keep them insulated, and then just tuck them away anywhere that they'll fit in the power supply. Okay, now after you've done all that, you're going to end up with a handful of odd colored wires, usually about half a dozen of them. One of them is going to be green, like you see here. One of them is going to be green. The green one, you can kind of think of this as a power wire, and essentially, in order for this power supply to turn on, you have to ground this green wire. Now you can do a couple different things here. If your power supply has an on-off switch built into it, which most of them do, usually right around the AC plug somewhere, most of them will have an on-off switch. If they do, then you can simply just take this green wire, you can solder it right up to a ground wire and put some heat shrink over it, and you're good to go. You don't need to do anything else. If that green wire is grounded, then as soon as you flip the on switch, it's going to work. Now if you don't have an on-off switch, you could technically still wire it that way and then just unplug and plug in the power cord in order to turn it off and on. But what I like to do is I actually like to use a switch. So I just wired it's just a simple on-off switch, and I wired up the green and the black wires to this on-off switch. I drilled a small hole and basically just glued it in place with some shoe glue. And now I have a nice on-off switch for my power supply. So the green one is probably the only, in fact it is the only odd colored wire that's actually important. None of the rest of the odd colored wires are important. If you have any other odd colors, you can just simply cut them off, heat shrink them, tuck them away, just like you did the rest of these here. Okay, the next thing you're going to need to do is you're going to need to install a 10 watt, 10 ohm sandbar resistor like this one here. And we want to install this on the 5 volt side. And so basically all you do is all you got to do is just solder up one of the 5 volt wires to one side of it and a ground to the other side of it. And I usually try to mount them to a existing heat sink inside the power supply, or if I have room, I will try to get them, I'll try to mount them like against this grate here, because the airflow is this is basically where most of the airflow is going to exhaust. So I'll try to mount them against this grate only on the inside of the power supply. Now this is a huge power supply, so this one is literally chock full of electronics. There's no room down in there to get one there. on this particular model, so that's why I mounted it here. This is nothing but a giant aluminum heat sink on both sides, so I just mounted it to that. Now the reason you got to do that is because some power supplies require a load on the 5-volt side to even turn on, and even if they don't require a load on the 5-volt side to turn on, they do require a load on the 5-volt side in order to keep the 12-volt side from sagging under load. Now the 12-volt side might sag a little bit under load, but if you don't have a load on the 5-volt side, there's a good chance that your 12-volt side is gonna sag worse under load than what it will if you have that resistor in there. So once you get done with the resistor, LED is optional. This particular power supply has an LED built into it already, so we didn't need to mess with that one. If you want to do an LED for yourself, all you got to do, and I'm going to switch back to the main camera here for this. All you got to do is get yourself an LED. It can be any color you want, doesn't matter. And if you've never messed with an LED before, just a real quick explanation. As you can tell, one of the leads coming off of the LED is longer than the other one. The longer one is the positive, the shorter one is the negative. Now if you've cut these off and you don't remember which one is which, there's another way to tell. And this is kind of hard to see, especially on the camera. But if you can see right here on this side, you see how the edge, if you look up here where the glass part is, or the plastic part, whatever this is, if you can see it, the edge there is flat. The side with the flat edge is the negative side. It's all that flat edge side is always going to be the negative side. So you should always be able to tell which one is which. Now, you will need a 1/2 watt 220 ohm resistor in conjunction, or to run in conjunction with the LED. And basically you just solder the resistor on either side. It can be on the positive or negative side, doesn't matter which. And then you're gonna hook up a 5-volt wire to the positive side, and and a negative wire to the negative side of the LED. Now if you don't have that resistor on there, 5 volts is going to burn out your LED. The resistor is to keep the LED from burning out under 5 volts. Depending on what color the LED is, you can try to use the 3.3 volt wire, but you got to make sure different color LEDs have different power specifications. Some of them can actually handle 3 or 3.3 volts without any resistor. Others can't. So the safer thing to do is just to put the resistor on there. They're not very expensive. It's not that big of a deal to put on there. You can get the LEDs and the LED holders and all that kind of stuff at Radio Shack. They're a few bucks. They're not terribly expensive. You can get the sandbar resistors off Radio Shack. You can get them off of eBay, whatever. Let's switch back to the overhead view here. So we've covered just about everything, I think, with the exception of the sensing wires. We still need to touch on the sensing wires. Now, if we take a look at this is the big 24-pin connector off the power supply. Actually, we want to look at the other end. If you take a look at this, you can see up here in this corner how there's 2 orange wires going into the same spot. One of them is slightly smaller in diameter than the other. That smaller wire is called a sensing wire, and there's actually 2 of them on this kit. There's a red one here on the other side. So there's two sensing wires on this kit. Virtually all power supplies are going to have at least one sensing wire. Some might have more than one. If yours does have one, you need to strip the end off of that sensing wire and solder it to a bigger wire of the same color. So, for example, on the 3.3 volt side, we had an orange sensing wire, and so what I did was I actually just incorporated that sensing wire into the other wires that I used for the 3.3 volt lead. That way they're electrically connected. And then for the red sensing wire, I'll zoom in here. For the red sensing wire, I just hooked it up. You can see the red sensing wire right here. I just hooked it up to this 5 volt wire that's hooked up to the sandbar resistor. That way it's electrically connected to a light colored wire as well. So as long as you've done that, your sensing wires will be taken care of, and that's really all you need to do to convert your PC power supply. It's a lot to take in at first, but it's really, once you've done it once, it's really not that difficult, and that's really about all there is to it. So just to wrap up here, if you have any questions or comments about any of this stuff, you can always email me at graywolfstudios74@gmail.com, or you can catch up with me on Facebook at www.facebook.com/graywolfstudios74. I also hang out at rcnitrotalk.com. If you're interested in joining a good forum, come over there, look me up, and meet some of the other cool guys that hang out there, and post up pictures of your modded power supplies. That's it for this video. I will catch you guys in the next one. Peace.